To build a virtual terrain requires numerous matrices working together to store heights, texturing, and detail information. This is not only true in Unity, but in any other application in which a terrain is required. At first glance, a terrain might appear to be a simple mesh constructed with equidistant vertices, but it is much more than that. A terrain mesh is constructed with a continuous level of detail algorithm, otherwise known as CLOD. This is basically a dynamic polygon mesh that provides more vertices to the areas that have more detail. That way, storage of the terrain is optimized, allowing flat areas to be represented by relatively few points. In this Unity terrain, you can see CLOD in action, adding more triangles as it becomes more intense over the feature definition. Although the CLOD mesh looks complex, luckily for us, accessing its data is not. With Unity taking care of all the behind-the-scenes clodding, all we need to do is to consider the terrain as a 2D matrix containing height values. Such a matrix is called a height map, and you will usually see them represented in grayscale, like this, where the whiter the colour, the higher the point. Here's a quick terrain made in Unity with its associated height map. The white areas are the higher parts, whereas black represents the lowest possible terrain point. Internally, the height map is represented as a 2D matrix of values, as we've already seen. These values are the equivalent of floats or integers that represent the grayscale of the visual height map. In Unity, these values range between 0 for the lowest point and 1 for the highest. They represent a scalar value that can be combined with a maximum height value to set the actual physical height of the terrain. For example, if a height value is 0.5 and the maximum terrain height is 500, then on the terrain mesh, the vertex representing that point will be set to 250. So although the same height map is used, by adjusting the maximum height, you can create different looking landscapes. Despite the CLOD algorithm working in the background and the triangle-based mesh, you should still consider the terrain object in Unity as a 2D matrix of squares. The resolution of the terrain is the number of squares along a side, and the terrain mesh is always considered square, so it is the same in dimensions in both width and height. For efficiency, the resolution is made a power of 2 value. What will slightly trick your mind is that the height map for a terrain is 1 plus the terrain's resolution. For a 512 by 512 terrain, the associated height map is 513 by 513. To make sense of this, consider a small terrain that is 2 by 2. This allows for a mesh that is 2 squares wide by 2 squares deep. However, it's not the squares themselves that are the height values. It's the corners of each square that the vertices define for each polygon. The shape of a mesh is determined by the location of its vertices, not its polygons. Now, for a 2 by 2 polygon terrain, there are in fact 3 by 3 vertices. You see, the values in the height map must align with the number of vertices in each dimension, and therefore we need to make the height map 1 plus the resolution of the terrain. Terrains have other 2D matrices assigned to them as well. These represent a variety of other features affecting the appearance of the terrain. For example, we have splat maps that define which textures will appear on what parts of the terrain and how they are blended together, and vegetation maps for adding trees. We will get up close and personal with all these maps and more as we progress through the course. Procedurally working with a terrain requires an intimate knowledge of all the maps, resolutions, and scaling factors involved in their generation. As the majority of this data is held in 2D matrices, you'll be seeing a lot of nested for loops like the one shown here. The basic process we will use over and over again is to extract the height map data from the existing terrain structure, loop around this matrix, modifying the values, and then updating the terrain with the new data. But before we start coding, let's start by examining Unity's terrain object and all its settings. And we'll do this by creating our own terrain in the next set of videos.